Hello. Good evening, everyone. The strength of infrastructure lies not just in what we build, but how we protect it. And that is exactly why we are here today. Not only to know, but to apply and do. As we bring world-class German engineering excellence into Indian infrastructure. On behalf of Permatech Concrete Solutions, I am delighted to host today's knowledge session on advanced injection grouting systems, discovering German engineering excellence for Indian infrastructure. This evening is truly special. We are honored to collaborate with Webac Chemie, a renowned German manufacturer with over 40 years of innovation in injection resins, waterproofing solutions, and soil stabilization systems. Webac products are trusted worldwide for their precision engineering, long-term durability, and proven performance. Their expertise in polyurethane, epoxy, acrylic, and silicate injection system has set benchmarks for quality and reliability. Today's session is a unique blend and an opportunity to experience German knowledge and practical solutions tailored to meet the growing demands to meet the Indian construction and infrastructure. Concrete gives strength, but protection gives us life. We are privileged to have with us Mr. Stefan, an industrial expert with an extensive international experience in injection grouting systems and engineering solutions. His deep knowledge and practical insights combined with Webac's legacy of excellence will guide us through today's presentation. We are equally honored by the presence of distinguished members of Waterproofing Association of India, the leading body representing professionals and innovators in the waterproofing industry. The active contribution in providing advanced waterproofing practices has been instrumental in shaping the industry in India. Now we will have a small inauguration session. I would request Madhu sir to felicitate our chief guest, Mr. Stefan. I also invite our dignitaries, Mr. Sripad and Mr. Raja Harrier, to kindly come forward. I would request you to do the honor of lighting the ceremonial lamp. Every auspicious occasion begins with invoking the blessings of Almighty. The lighting of the lamp is a symbol of knowledge, wisdom, and prosperity. May this event spread the light of learning and harmony. all join our hands together to welcome with a round of applause. Now, without any further delay, I would like to hand over to Mr. Stefan for the presentation.
Hello, a warm welcome also from me. Thanks for that nice ceremony. It's my first time here in India, in Mumbai, and I enjoy it, and it's really a heartwarming thing. It gives me more, let's say, power for the evening. Yeah, a warm welcome also from me, and thanks that you are joining this evening our, let's say, discussion, our presentation, our session about waterproofing. We all know what waterproofing means or what waterproofing is, but I hope I hope we see a little bit of some ideas, some background for discussion later on. So I would say let's start with the presentation and see what we can get out of it. So, yeah, I skipped that. Just before I start, some sentence about me. My name is Stefan Delarue. I'm working as a service technician or application engineer since 2008 in Webac. I have also a construction background. I have a master craftsman in masonry and also a master craftsman in concrete construction, which is the Chamber of the Crafts in Germany. It's a master degree, and you have to study all the things around construction, meaning by bricklaying and concrete work. Just a small overview of what Webac, who we are. Webac is a medium-sized family-run business. It was founded in 1978, which means we are more than 40 years on the market. The main products we are producing are for waterproof restoration, but also in the last decades for tunneling and mining as well. We have sales partners throughout the world and a subsidiary company in Poland, which are selling our products in the Poland region. Like I said, sales partners throughout the world where we work with them for decades. A main focus in our company is the research and development. So, like you see on the chart here, we develop new products. We have a high quality standard, which means we have a quality control about the raw materials. We have a quality control about the manufactured products, and all the products which we find in our canisters and which you are applying in cracks or wherever, they are our formulation, and last but not least, your solution. Also, a part of our logistic is the storage of raw materials and the storage of manufactured products, because we want to be sure that if you give us an order of the materials will be needed all around the world or in Europe, we are able to deliver in a short time. That means, I would say, 98% of our materials are in stock, depending on the, let's say, amount, but we cover all in stock to make sure that we are short enough on each job site of the world. By not only selling our canisters and our material, a big focus for us is also the training, which means hands-on demonstration, even if it's in our warehouse, in our house, or on job sites, on-site training and on-site visits. Especially if we have bigger projects upcoming, then we are also able to travel and to be present on the job site, discuss with the engineers and designers solutions, method statements for your targets, which can be done or will be done by me or my colleagues as an application engineer, or if necessary also some of our R&D manager is also available for special cases. Where are Webac products used? Well, a lot of points on the market, but the last point, restoration of the existing buildings, is our main focus in the Europe region, which means we have a lot of materials for restoration, for crack repair work, for injection against uprising moisture, but of course also other big projects like dam constructions. You see some pictures and maybe later some videos about these constructions, or tunneling and mining is also a focus of us. What are Webac products used for? Like I mentioned, for injection against uprising moisture, we speak about wet, damp or dry cracks, structural repair works, joint sealing, surface sealing for undergrade building components, all what we try to cover, which is the case on a job site. Through that, main product range is polyurethane injection foam resin, PU injection resins, injection gels, which are more and more common also for crack repair. For example, epoxy resins, silicate injection resins, and to cover all the systems, all the service around, of course, injection pumps, packers, injection tubes, which are a good solution, especially if you build up your construction, and swelling tape. So we try to cover all services around construction and waterproofing. Like I said, what does Webac offers? Innovative products. So they are all our formula in the canister, our knowledge, which we collected for more than 40 years. Complementary accessories, of course, the best product has to be applied with the best accessories. This is a needful or a necessary combination, otherwise it won't work. Quality for the products, service and training for the clients, customers, to be present on the job site. And of course, one-point individual solution. That means if we see that is a special accelerator or product needed for this kind of project, because of our R&D short ways to them, we can deliver a total solution for you, an individual solution for your case there. Webac walks on two different legs, I would say. On the left side, we have the classic line. So you see the building, it's more over on the upper part of the surface, not strictly underground. And the right picture, the right leg, is our consolidation line, which is more for underground construction, tunneling, mining, water stopping, but also for soil stabilization, soil improvement, which comes more and more also in Europe because of the climate change. And just to start with something, we start with our classic line. You see the whole variation or varieties where you can use the products, but we go a little bit more in details if we speak about crack repair and waterproofing. Here you see special, in these pictures, you have variations of cracks. We have different options to seal the cracks, and this is the point where I want to talk a little bit if we speak about the standard or the standard product line, the classic line. Just a short overview, what we have to observe or what we observe every day on the job site. If we speak about crack repair, we speak in Europe mainly, maybe also worldwide, about the crack repair norm, which is the 1504/5. And this, what I show now in a short table, is what we face every day. So we face dry cracks, where we have no impact of water, which is one case you have on the job site. We have damp cracks, where we have signs of recent water discharge, which means we have black or dark shadows beside the crack. That gives us the indication, oh, it's damp. Therefore, we have to choose the right material or to choose the right renovation. We have wet cracks, which is, I would say, 80% of the cracks that we find on the job sites. We have water leakage, we have dripping water, let's say a small amount of rinsing water coming out. And this is what I actually like, because this is a big advantage. We have flowing water, water pressure. This is also common on a lot of job sites, especially if you go down in an underground pit and you face a lot of groundwater which comes into groundwater, including salt or whatever will be flushed in. So these are the four cases that we are facing. according to the norm. And these is the which means we have swelling products, swellable products. I will come back to that products later, which will also be now applied in cracks. Let's go a little bit deeper in the let's say in the theme of the crack repair work. You remember the last case, water stopping, water pressure, what we have in job sites. Therefore, we have injection foam resins present on the market. Also Webac offers different types of them. Here we speak about the 15 numbers of Webac. This means we have high expanding of the resin after the resin gets in contact with water. That gives us the opportunity to block temporarily sealing by an open pore foam structure. That means it is necessary for permanent waterproofing to pre-inject after you stop the water. This is according to the regulation of the crack repair work, but they are mostly water reactive, and in cases there's no water, they won't work because they find no partner where they can react. Yeah, some words about the foaming factor and the viscosity. We have a viscosity of 600 megapascal, but what you see is the reaction time after the mixing and contact with water is roughly 14 seconds. 5 seconds. The important thing is that if the foam starts and the end point isn't so far away, otherwise you lose a lot of material and it will get washed out because of that water pressure behind. I hope it works. So just a small demonstration as an animation video. We did some crack repair in our training center, in our training area. This will be used for our training sessions, for our seminars, that clients get an overview, or new clients to waterproofing get an overview, an idea how to apply the product. This is the product that we spoke about, 150. It's a mixture, you fill it in the pump, and if no water is present, the humidity, yes, but you can also apply it the next day, it doesn't matter. It will not react in your pump because there's no water. And here you see first the pre-injection. Let's say we stop the water, the post-injection. Now we come to the pre-injection point. We inject with a polyurethane resin to close that cell structure and to push out all the last water which is in the structure himself. And of course, the plastering point at the end of the day. Remove the packers. You know that because I guess it's the daily business that you are doing. Just a short video of a colleague of mine to give you an impression about the foaming factor of the resin. So it's a 2-component resin, of course. The mixing will be easy, it can be easy done because it goes 1 by 1, measured by volume. We have no kilograms that you have to measure, complicated. So it is easy to mix and easy to measure on the job site. You fill it, mix it, and of course, for each product range or product, name it epoxy or polyurethane, we have also special accelerators if needed. Let's say if it's too slow for you, we can accelerate it to a faster system. So now this is your pump hopper. You fill it into, nothing has happened. Maybe a fine skin will on top, but if it will be injected now in water, via your pump, via your packer, this will be happen in the crack. It will be, let's say, pushed into the crack, and after a couple of seconds, the resin will react. And this is what you want to achieve You want to achieve a fast reaction to minimize any outflow of your resin which you pump into. There are some tricks. You can overcome them, maybe you inject deeper or something else, but these are technical tricks. But this is the performance, the pure performance of the resin. Now we have roughly, I would say, a foaming factor of 40 times, depending on the, let's say, on the mixture, on the turbulences. And my colleague will open now the foam that you see the fine pores, the fine structure, which pushes the resin also deeper in the soil. So it's really brittle after a couple of seconds, and he will open it. And it's a fine open cell pore structure. That means you have to pre-inject if you want it permanently. This is free expansion. We all know in the crack we won't have it. We will only have 2 times or maximum 1 time. One time or maximum 2 times. So also an open pore structure, open cell structure can be waterproofing your crack for a period of time, depending on the pressure which pushes out against your crack or against your joint. So between, let's say, the foam resins and the, let's say, pure rigid injection resins, polyurethane injection resins, we have so-called combi injection resins. They are foaming, but not with that haze we saw before. Here we have a flexible structure, and it's a closed cell structure. Before we had the open cell, this is a closed cell structure, slightly expanding, and they react with or without. In parts where they find no water, they react. In parts with water, they start foaming, create a slightly foaming, which pushes the material deeper in the cracks or in the soil structure and gives the water proofing. This is the difference. The most common products coming out of the last year or were developed the last years is a real monocomponent resin, which means you have only one product on the job site, one polyurethane resin, and the reaction starts as water. That means you don't need any accelerator or catalyst to that. You can accelerate it, of course, but it's not necessary. So the reaction partner of this type of material is water, and nothing happened in the pump, so you have only one canister. Mixture failures will be not done. So you grab your can and you inject, and you have a permanent closed cell structure. And also such kind of products are tested according to the CE norm, according to the crack standard, the European crack standard. Foaming factor, remember the last one was 40 times. Here we speak about 22 times, roughly. Then we come to the pure injection resin, which are for permanent sealing. It's mentioned in our 14er row. They are also water reactive, slightly expanding, cures with or without water. They have a good elongation. You see the crack width between 0.3 or 5 millimeter. We have an elongation of 5%. Wider than 5 millimeters, we have 0.5 millimeter. We have an elongation of 10%, which is, I guess, really, think about you have this fine crack and you have that elongation. That is totally enough to cover a lot of, let's say, movements. And one point which is marked a little on the last point, variations with high strength development are also available. I mean, there are polyurethane resins where develop a strength development compared to an epoxy or compared to a high-end concrete. We speak about 60, 70 Newton per square millimeter. I come to that shortly. But here we see, let's say, a reaction of such kind of a form. Have a look on the viscosity. We speak about 80, 90 megapascal. If you have it in a canister, it's really liquid. That gives us the possibility to penetrate in fine cracks, in fine fissures, and in deep structures. This is now not real time, it's a time loop, because we want to push the material or inject the material deep as possible. If it would react earlier as a foam, you are not able to get into the depths, which is important in this case. So a slightly foaming, for that product I calculate roughly 5-time expansion or 8-time expansion maximum. So this is what we talked about. You see the viscosity, roughly 90 megapascal. In that areas here where we have high temperatures, the viscosity will also be pushed down. I guess we speak about 60 megapascal here, which is really low viscous resin. Reaction time starts at 2 minutes, 3 minutes, depending on the moisture that we have inside the crack. And it ends roughly like, foaming ends roughly between 5 and 10 minutes. But the pot life of this material, if you mix A and B together, it's 120 minutes. That gives you a lot of time to go forward with your injection, jump back, re-inject, so push it as deep as possible in the structure, and you are safe that you do a good waterproofing at the end. This is one of the products, Webac 1660, I mentioned before, that you heard about it, polyurethane resin, which develops a high bending tensile strength and a high strength development inside the crack. Here we speak about 70 megapascal, 70 Newton per square millimeter without any contact of water. Of course, it will slightly foaming, and this minimizes the strength development, but at the end we are always higher than 35 or 40 Newton per square millimeter with a foamed product. It will be used in concrete where you had a bad pouring, where we have some honeycombs. So it fulfills two targets. It gives the waterproofing on one hand, and on the opposite side, it gives you strength development to the, let's say, weak concrete or areas where the concrete is weak. Then we have, of course, epoxy resins. This is the case where you think about we have dry conditions. Therefore, epoxy resins are a good solution, a good development for such cracks. We have highly tough and solid, a good bending and tensile strength of the materials, a good adhesion to mineral substrates, which means the crack edge at the end. And there are some modifications where you can apply an epoxy resin in dry or wet conditions, and also in oily cracks. Let's say you have a warehouse and there are some trucks driving and you have crack repair work to do, and there's contaminated with oil. There are some possible available products in our range where you can inject into that oil contaminated cracks. Okay, doing some preparations first, but to seal that cracks with that kind of resin. If we speak about crack repair, we have 2 options given for that. We have surface defilling, which means by gravity. I guess you know that sometimes it's not necessary to drill into the structure, especially if the cracks are, let's say, more on the surface, not so deep. Then in some cases you open that, you cut that crack a little bit, and you can fill into mostly an epoxy resin. If you would use a polyurethane resin, the foaming will be some critical because you can't penetrate deeply enough. But here we recommend to do some filling with epoxy resins, and this is 95% what you do outside. Drill the crack, drill through the crack, get the crack drilled in the middle of the structure, and then start the filling. Because then you are using high pressure, which pushes really deep into the structure, the material that you choose. Some examples was additionally done. On the left side, we did a crack repair where we not drilled the packers. I'm sure you used that also before. There's some surface packers available. Let's say if you are not able to drill or not allowed to drill for any kind of structural reason, then you can use the surface packers. You patch that with an epoxy resin, especially in the vertical application. It's necessary that you patch it, otherwise the resin will disappear. On the right side you see the filling by gravity. So we prepared the crack, make sure that everything is clean, remove the dust which is present in the crack after your grinding or after your drilling, and then refill it with an epoxy, and whatever you put on top of it, we prepare it with a little bit quartzite on the surface as a good grinding basement. And like I said before, if you finished on the last packer, go back to the first packer, re-inject, because the material disappears in fine fissures and you have to refill your crack. Otherwise, maybe it's it's not enough filled. The target is 90% should be filled. So that's the reason why you should always go back during your pot life, of course. So here we come to a point, you remember the last point, swellable products or swellable category. If we have this, we speak about acrylic gel. I guess you will heard about this or you applied it. It comes mostly, first it was done as a curtain injection against moisture coming through your building, but it also can be fitted for cracks because of the low viscosity we have there. But the advantage of such kind of product is a high adhesion on dry and wet surfaces, which is really high. A high dimensional stability, so it is really flexible outside in the soil or even in the joint. High elasticity, and it is CE certificated with a polymeric version. That means you can also inject it into cracks to seal the cracks and to waterproof the cracks. National technical approval is also available, and one point I'm not sure if it mentioned later on, but all the products we developed are solvent free. There are so no critical ingredients inside, and an important thing, they are all tested according to drinking or potable water certificates, which means if you inject into groundwater or into drinking water areas, if the product is mixed and it's cured, there's no issue with the groundwater. Just to demonstrate you how such kind of acrylic gel is working. It's also a EIB component you prepare first. And it's not a time loop, it's real time. So it's like water, but from a certain point it starts increasing the viscosity. This is the point where the water can't be diluted, the material, and where it starts its sealing effect. Another advantage of such kind of material, you can apply or you can adapt it to the needs on the job site, which means if you have flowing water, pressing water from the movement joint, for example, and you can add more accelerator to it to make it faster, or you can slow down the reaction. For example, if you want to spread it in the soil with less permeability, then you can reduce the reaction time down to or up to 15 minutes. It gives you a good penetration range, so it's adaptable on the needs or on the job site. This is where this product will be mostly used. So we have a curtain injection. That means that protects your building against moisture which pushes up from the outside on the whole surface, not only on the crack but on the whole surface to your building. Just an impression how you install it, how you apply it. You see the difference between standard packers is we're using bigger packers, wider packers, because we need the material, we need a higher material flow outside, behind that building, to create a curtain. And from the technician side, if you finish with your work, the advantage here is you can clean properly the pumps with water. There's no cleaner needed. So flush the pump with water, which is also environmental friendly point. No critical substrates to clean the pumps. And how these products are working, the moisture inside the soil will give the, let's say, the flexibility and the adhesion of the material. And of course, it is also necessary that you re-inject, if you finish with your last packet, you can re-inject the first packet to make sure to put behind the curtain before to get a proper and closed sealing behind. This is a mock-up that we use for our trainings, and you see the bubbles, which gives you good overlapping. You can't see it in the soil, but here we see it good, and the clients try some options to inject, and if we open it, they are surprised. They think, okay, we penetrate everything, but there's a hole there, there's a hole there. So it needs a little bit of some experience to know to get to build up such kind of a curtain. The product or the additional component that we can add to this is a polymeric reinforced component. It's like a milk, white milk. The advantage of such kind of products is the higher adhesion compared to the standard acrylic gels. Because of that reinforcement, you have less shrinkage. You have also adjustable reaction time. But the main important thing where the product will be used is, like you see on the sketch there, is movement joint sealing. So if you have movement joints, 2-3 centimeters width of the joint, therefore these products are specially developed to create a good adhesion on the joints or edges and to create a proper waterproofing. To show such kind of adhesion, we prepared a joint during our seminar here, and there was no, believe me, there was no preparation on the concrete surface. So it's pure material that we added, and after 1 hour, if the material is really rigid and cured, you can do this with your joint. But I think, or I guess, if you have this in a joint, you should better run, because there must be a bigger problem. This will be not happen in a standard joint. And all joint sealings you have, let's say, in the middle of your, like membranes or whatever, that's not a problem for this material to get a good adhesion to foils or membranes. Because of that reinforcement and polymeric component, this creates also adhesion to most all critical membranes on the market. And here, worst case scenario, like I said, if this has happened, you should be on the other place. Here, some ideas about an application in a tunnel. We faced a lot of projects where they installed some membranes as a waterproofing behind TBM segments or shotcrete, and because of some demolitions, we have to seal it, and therefore such a material with a good adhesion factor on each kind of membrane or sealing compartments in tunnels is a good solution, a good idea. So that was an overview about our first leg that we are walking, about the standard products, about the classic line. Now we jumping more in the underground areas, you see that here. So that means tunneling, micro-tunneling, or also bigger tunneling, TBM tunneling, mining, dam construction. Therefore, there's the consolidation line developed, which gives you a similar product choice like we know from the standard line, but with some different, I would say, modifications. Here we have injection foam resins, we have the injection resin that we had before, but here we have silicate injection foam resins and silicate injection resins and hybrid system. Last point, I mentioned that later. And of course the accessories, the injection pumps, and here we are speaking about bigger pumps, we are speaking about pumps who deliver 15, 20, 30 liters per minute, which are sometimes necessary to stop water ingresses or to fill cavities with such silicate foams. That was a job site in the photo on the right side is a job site in Peru. I will show some pictures later on about this job site. That was interesting. So, just a short idea about such kind of an application. Accessories, the last point here, my colleague Maurice is demonstrating that. That means ram injection lenses, drilling lenses, whatever are needed. We have also the option to provide them. And you see here, this is how it will standardly be done, drilling or setting injection lenses in a certain distance, which we talked about with the designer to make sure that we have coverage of the soil, overlapping of the soil, and then the material will be injected. Here you see some openings. There are some different versions of injection ram lenses available with a loose bit, without openings. So there is a good range to adapt on the needs of the job site. Also easy, no big technical preparation for the mixing. And one important point here, we speak about two component systems. Not one component, we speak about two component systems because of the, let's say, faster reaction and the faster, or let's say, of the different reaction times of the products themselves. Let's start with the foam resin. You remember the Webac 150. Here we speak about push-stop 1C. It's a polyurethane resin where you can add an accelerator from 1 to 10%, which gives you different ranges on the foaming factor, on the reaction time. Here we have a 60 time free expansion, which is a little bit more higher than we know from the standard line. But the reaction time, the starting and the end, will be similar to each other foam. And this is, like you heard before from the standard line, from the classic line, it's also an open pore foam structure, cell structure, so that means we have to pre-inject if we want it more waterproof or for decades. So this is our polyurethane resin. Webac Pursil, you remember the 14 row in the standard line. The picture right will show that the material reacts in cold temperatures. Okay, this is not the case here, but in most areas in Germany, we have that cases, that means it's ice, and if it's minus or 0 or 2 or 3 degrees, it reacts. That gives you the safety also in cold conditions to do a waterproofing with that kind of material. The flow limit of the standard version is roughly 40 or 60 seconds, depending on the temperature. That means we have a fast setting time. That means we have to work with two component pumps. The foam factor is slightly between 1 and 4. This is totally enough to use that kind of material as a water stopper. The important thing is 80 Newton per square millimeter, of course without any foaming. That means this material can be used for anchoring as well, or for soil structure stabilization or slab lifting, what is in each mouth the last years. But compressive strength development is a big advantage of this product. And I would say it's a toolbox that I have in my pocket. Toolbox means foaming agents and accelerators are available. That means it can be adapted to your needs on the job site. If you have water ingress, add some accelerator or foaming agent to the product, that gives you a reaction time down to 10 seconds, which is really a fast setting block, and then you can switch to the standard version. But you have a toolbox in your on the job site in your hands where you can play with it. This is an important thing that I like on several job sites. You are able to react on each kind of situation that you have. Webac Sil Fill. Sil means silicate resin, a silicate foam resin. Such kind of products, silicates, will be used more in foam resin, more for cavity filler, not especially for waterproofing, because we want to fill cavities. The photo shows a job site in Italy where we did this injection. I come to that back later. But it's the target with the foam resin is to close the gaps, to close the voids, and last but not least, to stabilize loose rock or gravel. Reaction time is really fast. We speak about 30 seconds, then the foam starts. But keep an eye on the viscosity. It's 50 MPa. It's like water. But after 30 seconds, you get a high expansion of that, and you get a high foaming capacity and the lightweight foaming with a 30 times or 40 times of the foaming factor. And like I said, it's not for waterproofing, but here we're speaking about cavity filler. Sil Compact is a brother product of the Sil form, of the foaming material. It is a high viscosity, it creates a high viscosity after mixing. That means if you pour it in water saturated areas, it will be not as mixed. So you push out the water with that kind of resin. So it means you can use it for soil strengthening, for anchoring or whatever. Here we did some tests where we anchored overhead. There's a thixotropic version, so you pump it overhead, and if you stop, the material stops. It will not flow downwards again. So as long as you're pumping, it flows. But if you stop, if it's enough, you stop and it stays. So the material himself delivers a high compressive strength, 75 Newton per square millimeter, which is a great material for anchor bonding, for example, or for soil stabilization or loose rock stabilization. One product we developed the last years is our Webac HIS hybrid injection system. It is a product, a polyurethane-based product, a two-component product, which you can add to your cement stream. Admixtures which get added to cement to give a faster reaction to the cement. This is what we want to achieve also with that material. You want to achieve a thixotropic effect to the cement. Let's say you have a movement behind the segment and you want to grout it and you pump into cement and the cement will be washed out. This can be an option by adding a 1 to 5 or 1 to 10 parts, or even 1 to 30 or 40 parts. One part is the resin, 20 or 30 parts is the cement. To your cement stream, this creates a thixotropic effect, and the cement will be, let's say, rigid on that place, and you won't have that huge outspoiling or wasting of a cement grouting. How does it work? The upper build shows the cement blend that you know that you have on the job site, also the local cement. And by adding or by installing a two-component pump, here a small gear pump, and a flow measurement where we can control the mixing ratio of cement to the grout, which will be added to your cement stream, you create different versions of the product. The left side, we did on a job site a test where we added 1 part of cement and 2 part of resin to see if we get a foaming. That worked. And on the right side, it's not a video, but this shows the thixotropic effect, which will be added to the cement stream, which gives you the ability to block, to stop, to set a block with your cement and then shut off the PU pump and go backwards to your standard cement injection. It's not necessary to use the product permanently. Only in cases where you have some issues, then you can apply that product. Okay, that's the end of the first presentation. I prepared some additional slides for you. I hope it works. You heard now a lot of the products, and I don't want to confuse you, because you hear PU there, and for me it's that's what I always use in seminars or on-site trainings or site meetings, to show cases, real cases where we are involved and which maybe are well known. Maybe you stood in front of a wall or in a tunnel and you faced that problem. So this is where I think where we can demonstrate and talk about these situations and give some ideas how to solve it, where we solve it, where we can solve it, and makes it much more understandable. So you remember that picture, we come to that later. So first, you start with a silicate foam resin. Sorry, I forgot, silicates are cuttable, and this is an important point if you have to strengthen or you have to inject in front of a TBM, for example. Because this gives the option of the TBM cutter head to cut through that consolidated area. If you would use a big amount of polyurethane resin, maybe the risk that the cutter head stuck because of the gluing effect. If a polyurethane gets warm or heated, it will start gluing, and maybe that gives you some difficulty for your cutter head of the TBM, microtunneling, whatever it is. So therefore, silicate resins are designed to drive through, to cut that through, and to dig through that consolidated area. So coming back to the job site in Italy, that was a rehabilitation of several tunnel sections there. You see one of these tunnels here, and it looks nice, bright and shiny if you in front of it, but we entered it, and the case here was why we have to use silicate foam resin was they they did some drillings, some core drillings, and they figured out some big, wide, huge cavities on the ceiling of the old tunnels. And first the decision was, okay, using a cement, of course, but the thickness here of the concrete wasn't so thick in the back or in the middle of the tunnel. So that means if you inject a lot of cementitious grouting, you have a lot of load which comes to that point. Therefore we decided, okay, let's move to a silicate foam resin, which is a lightweight material, lightweight cavity filler, and also stable enough to protect the rock or the gravel from falling down. It's the last point, cavities and fissured rock above. That means it's dangerous to widen that tunnel because that was the target. The target was to widen that tunnel, to make new infrastructure inside. Because of more traffic there, they need a wider tunnel on the case. So this is how it started. The first on the step for the standard products, we have to do a site investigation. Here, for underground injection, we don't know nothing where the material goes. We have no insight because we can't control it. So therefore, it is important to have a geological profile or to speak with some geologists to get the knowledge what soil we are facing, what is the permeability, that gives you at the end the choice of the material and the choice of the, I would say, equipment and accessories that are necessary for successful sealing. So if you have some geological information, you know more about the structure, then you can find a suitable material selection and the specific distance between each drill, or which drill size you have to choose. The red marked points there are the openings that we drilled. We drilled with a diameter of 50, DN50, to get a good access to the let's say, cavities behind. And cavities we speak about, I couldn't believe it, but I took a lighter and I looked into a core that was that size drilled out, and there was a huge cavity. It was, I guess, 10 cubic meter of nothing inside. So this has to be filled step by step to make sure that if you widen the tunnel, like they do here, this is the tunnel, that everything is safe for them, that everything is fine to get that work done without any risk. The yellow parts on the opening section, this is the silicate resin, and yeah, it was a successful process injection there. And last but not least, the client was a little bit skeptical about it, but at the end, if he saw the result and he saw the after the first test injection, he saw the result and he saw the advantage, it was accepted, and we did, I guess, 3 or 4 tunnels with the same system. Other thing is, you know that if you use chemical injection, you're always faster. Cement has to be cured anyway, that takes time. Chemicals are much more faster and develop more strength in a shorter time. Okay, another product, here a sealing of movement joints. You remember the acrylic gel, the swellable products for that. Here the B-seal, the polymeric reinforcement, because we speak about movement joint, width of, I guess it was between 3 and 5 centimeters. There was water stop mounted in the middle of the concrete slab, but the water was coming out because there were some damages of the water stops, of the water stopping profile. So we had water pressure here, and the tunnel was in the near of the harbor. And another effect here, because we tested the water before, it contains petrol. That means some resins are critical with that. Maybe they get not that adhesion, or they get not that brittle thing that you want from them. So it contains petrol, and that was only also the decision to choose the BZ, the polymeric reinforced version, because there we have a high chemical resistance of a lot of substrates on the material. So the left picture shows the setup for such kind of an injection, the A and B component, the 2-component piston pump. Here we recommend a stainless steel version because of the reaction starter of these products. It's salt based. You can use a standard pump, but you won't have any. It will stay not so long as compared to a stainless steel pump. Yeah, the setup is done. It's a 1x1 system. That means measured by volume. And here I show the application itself. So you both lines A and B will separate it, push to the mixing head, and in the mixing head you get that mixture. It's a small plastic mixer, totally enough. And you see the material will be injected, and in a movement joint it's easy. You start on one point, you drill a lot of packers, but immediately it flows and it fills the whole joint easily. Here you see the water get pushed out. It gets white now. Then we know, the polymeric version is there. Here we have the pure water, but here also the white one, the white milk is coming out. That gives us the sign that the material is pushed in each kind of region. And here we worked with a stand-up setup. The reaction time there was roughly 1.5 minutes. But like I said, you can, by adding less salt, you can have 10 or 12 or 15 minutes, depending what is the injection target, what is the design behind that. This is a picture afterwards. They installed some steel plates on top because there were some small cars driving over that to protect the, let's say, the joint against any mechanical damage. But this is, you remember at first, it was all wet, now it's clear, everything is fine. So we injected the whole section with a polymeric version, with a polymeric reinforced acrylic gel with good progress. So this is a job site where I want to show you, or where we speak about the toolbox. You remember? Polyurethane plus accelerators and the super fast accelerator. It was in Italy. The challenge there is cold water, 2 or 3 degrees, and cold building temperatures. This is also, okay, not here, sorry, but in Germany or in Europe you have also the cold building structure temperatures. This minimizes the reaction time of your material. That means you need accelerators for these kind of works. But here, that was the case. Cold temperatures on the building component and the water, which faces us here. It was a tunnel from a hydropower plant. The diameter was 170, it was, I guess, 190, roughly like that. The logistic part was also bring the pump and the material to the injection points. We speak about 500, 800 meters. So it was cold outside, -20, but if you carry the canisters, you will be warmed up easily. And a closed space for the working also there. You see the tunnel himself was a concrete lining, but because of some rock movement, they had damaged and they put some steel inliners into that in the past. But because of now additional movements, there was some water leakages coming out of the connection of the steel liner to the concrete. And this is what we faced here. Just think about it's 3 or 4 degrees of the temperature of the water. So this is one of the injection points. Of course, we had some cracks where we also injected, but we had also more pressing water there. This is before we started the injection. On the left side on the picture, you see the distance we moved away from the sealing point. This is because of the cold temperature and because we use the water stream, the water movement, which goes, let's say in this case from left to right, as a reaction starter for our material. So we pumped in the resin there, it starts foaming immediately because we had to accelerate it extremely, and this creates bubbles. And let's say here we see, I think it was maximum 2 meters. From the injection point to this point, these 2 meters are totally enough to create some bubbles and to create a block after a certain time. And if you have that block, if you see that, this is during the injection, you can probably switch back to your standard material because then you can pump easily to go wider into the structure. And this is after the injection was done. On some spots you see some bubbling. There you see some bubbling. That means that the resin is always in a process. It's reacting afterwards here. So that means maybe if this would be leaking, when you would come back the next day, it will be sealed. Because the resin is always working, especially in cold temperatures, it takes a little bit more time. And there we pre-injected it with the standard version, just to push it far as possible. Therefore, it reacts a little bit more slower. Like I said, I won't miss that toolbox. Like I said, we can adapt it to the needs on the job site, and mentioned again, drinking water certificate system, no problem in potable water areas or groundwater areas. Okay, that was a case where we faced in Peru. A tunnel, you remember that there on this building site we took that picture. This is what we had there. You see that big fountain or big river comes out of the mountain there. That was a special case. I tell you, we fixed we fixed mostly all of the water leakages there, but that wasn't possible to do only by using injection material. It's not possible. So I hope I can push that a little bit forward here. Yeah, okay. Okay, that was the hydropower dam in Peru. We sent over material because the target first was doing some strength repair or consolidation in front of the shield of the tunnel face. We went there and they came up and look, you are here, but we have a little bit of a water problem. Can you come visit and see what we can do? And they shifted us to that point, and at the end they want to do waterproofing. Lucky that we had the toolbox with us. So at the end we injected roughly 15 tons of the polyurethane resin, including accelerator and foaming agent. Water ingress was 220 liters per minute. Pressure tunnel. There was also an issue. We used special R32 rods to inject. The factor here is it took 1 day for them, because of the equipment, to drill us 3 or maximum 4 anchors. So that means you have not so much chances to inject and to get a waterproofing. Now, that's some circumstances there we faced. And on the left picture, you see we started with the injection, and I'm not sure if you heard about this. For this case, we used also injection lenses with inflatable packers. Inflatable packers, that means you push into your borehole, you start your pumping the resin, and the packer will be inflated. That's will seal the borehole, and after a certain time there's a burst plate. If this is bursting, your resin will be released outside in your borehole or in your anchor, and you start the injection. And on the right side you see we fixed the most problems, but you remember the big water stream there, that wasn't possible on that point. So we decided, we talked with the designers and with the owner, and last but not least, that was also injected, but with some technical accessories we applied. First, they applied a huge, thick metal plate on top of it, where we installed a huge ball valve in the middle to release the water pressure. And then we drilled from each angle as good as possible, as deep as possible, to inject the cement and to inject our polyurethane. And after that, they applied also shotcrete on top of it, so it is done. We closed that ball valve step by step. If you see some progress, and with luck we get this done, but this was really a hard fight against the water stream there. So, some pictures about microtunneling. I heard that you also involved maybe in some projects. That was a micro-tunneling project in Denmark for a dewatering project. The diameter was roughly, I guess, 190 or 2 meters. So the TPM entered the shaft, and they removed the TPM, and they faced the water ingress. But not only water, the worst case is if soil is coming additionally. And therefore, we had to do something. Cementitious grouting wasn't possible. We had to waste a lot of time and material. So last but not least, we used also the toolbox, the Webac Proseal toolbox for that case. And there were only 4 access points inside the tunnel liner. That means you have 4 options for the injection. And we want to seal it in a certain time. And therefore the decision we did, similar to the previous project in Italy, we went back, we switched back 8 or 10 meters and did the same. Injected, used the water stream, and sealed the whole area around with our toolbox here. Okay, some loose soil or ground improvements, which are more and more common because of the drying out of the water, especially in Europe. Then you have cracked, your foundation will collapsing, so we have to do something under your foundation. That was a project where we have to stabilize the loose rock and gravel under that railway line. And the target here was that we don't have to achieve any lifting. That was critical. So we decided to go with Proseal and a slower version, by the way. But anyway, the injection was done from the surface. We drilled through, injected. Here you see the joint between 2 concrete slabs. And don't be scared about this. This is wanted because I want an opening for a pressure release. That means each side, it looks more than it is, but each side the pressure has to go somewhere because the resin develops a foam, and the foam creates anyway pressure. And like I said, there was no lifting wanted, so we released that, and on that length of 2 kilometers, they measured it with a special railway measurement or railway train. We have no lifting, so that was the target there, and they were satisfied. The target was to consolidate the gravel and the ground under that point. So another interesting project where we used, in this case, our standard products, our fast foaming PU resin, Webac 150 and Webac 1403, so the standard line. It was the Marmaray project in Istanbul. There was a new railway with a total length of more than 76 kilometers, and a construction of 4 metro stations and 4 metros. And they had the Bosporus crossing, which means they connected Asian to the European side. And this was done by immersed tunnel segments. So immersed tunnel segments, they were produced in a concrete on the harbor in a concrete factory, and they will get pushed out, and they will be sink down to the place and will connect it, and then you have your tunnel prepared. So this is an inside view of such a station there. You see the water, which was really high in that area, and in some cases here it was easy because we reached each point, but in some cases there was some accessories mounted, which was much more difficult. But last but not least, the worst part here was, or the worst case here was, the connection between the tunnel station and the tunnel to the station. Therefore, for the waterproofing, they used the membrane system, but we know membranes can be damaged. This was the case here. So the water, all of the, let's say, Bosporus area enters the tunnel, and we had to find a solution. So on On the left side, sorry, it's only a picture because during this time we had no cell phone or to make pictures. I used the standard photo for that. So on the left side you see the water pressure coming out between the membrane and your concrete. And on the right picture you see the design or the idea how we can fix it. So we drilled through the concrete line directly through the outside, through the overcut, installed packers and injected first a foam to block the water, to reduce the water stream and to make sure that we have a good basement for post-injection. Post-injection with our Webac 1403, you remember the rigid polyurethane resin with a closed cell structure and a flexibility and a waterproofing for longer decades. Here the measurement shows where we drilled. Of course, you see we moved 1.5 or 2 meters away to create a row, and we injected the whole segments around, not only one spot, all around, as good as possible. Because if you do one segment or one part of a crack or one part of a corner, believe me, the water will find a way. It has, let's say, a thin head or whatever you call it, it finds a way. And after that progress, they called us and they asked, do you want, can you carry out a test injection in the segments inside the tunnel? Because they did some waterproofing or they tried some waterproofing without any progress because the material they used was too rigid. So they have a movement in the tunnel because of the movement of the water and all that stuff. So that cracks any time and the water comes into. And during this case, or the complicated thing or the bonus for me was they want a similar material performance like they know with that material that they used. Okay, like I remember, we do one day, or we can do some tailor-made products. So I rang up our R&D and asked them if they prepare me some accelerator where we can add to our material, to our standard material, to create a similar performance that they want. Because that gives us at the end the permission to do additional injections there. So we injected the joints there with good progress. You see the material comes out. It was necessary to inject the whole TBM line or the tunnel line because on top of that concrete they applied, let's say, fire protection mortar, and therefore the surface has to be dry, so there should be no dripping water because that will minimize the adhesion.
And what will be the worst situation, like it may go toppling down effect or maybe the pump up effect at some other different place.
Okay.
No, like, sorry to interrupt again. We don't have any design drawing, we don't have nothing we have on the document. Whatever is have, we have a physical site and then we have to do it.
Okay. So, first, you remember, important is if you do an injection behind any structure where you can't see anything, let's say you're in the soil, it is important to know what soil conditions we have there. Do we have sand? Do we have sand-gravel mixture? What loads are on the building which have to be released in the soil? These are important things that we have to know. Permeability of the soil is important. And then we have to work together with designers, geologists, which gives us an indication about the length or the depth that we have to inject. The distance between each packer. This is what you calculate if you know the permeability of the soil. If you have, let's say, low permeability, or let's say if you have more rock or more gravel or whatever, and depending on the material you are using, let's say we talk about polyurethane resin because of the strength development. The distance, from my experience, is roughly, usually, between 60, 80 or 1 meter, 1.5 meter of each lens, depending on the soil structure. This is a good distance that you can achieve. But last but not least,
Length of the pack. What about
the length depending on the depth that we have to reach. That gives maybe the designer, or depending on the load that you have to cover with the soil, including the improvement, and that gives, let's say, the indication of the length of the injection lenses.
Any Indian case study you have?
I can speak from my experience from the last years. The length of the lenses we are used was between 2 meters or 10 meters. That is depending on the soil structure. Let's say if we have a clay layer and let's say loose areas on top, 3 or 4 meters, and the clay is stable clay layer on the bottom, and they want to achieve some piling with that, or want to achieve an improvement, then it's not necessary to go deeper than the clay. Makes no sense. Be in that level. So, but this depends on the soil conditions and also on the conditions of the soil. Is it dry? Is it wet? Is it water saturated? Some influences have also characteristics to that applications.
So you mean to say first we need to take the bore log?
Pardon me?
You mean to say first we need to take the bore logs?
Yeah, you have to drill through. You remember the video where you push some anchors or some lenses into it, and you can remove them or you can leave them, but this is depending on the target. It is really necessary that the client, the designer, and the geologist sit on one table and develop their strength development. I know this is not often common. I try to push our clients or push the designer into that, but I always recommend, if that isn't 100% clear, carry out a test injection. Carry out a test injection, take a core, or carry out the test injection in a similar condition, maybe on the outside area or whatever, to see let's say the spreading, the permeability option of the soil, and to see the strength. This can also, this is what I also sometimes recommend if I inject cracks in a soil, in a concrete structure with a wider thickness, to see what is the crack disappearing, or carry out a test injection gives you the best background especially for soil injection, best crack background. It costs money maybe, but that will be paid back later, because then you are in a good shape and you have a good result at the end.
And when you will stop injecting?
Okay, this is a point, sorry I forgot. This is a point which is also a soil factor, permeability. you can, the easiest way to control it, if you know the permeability per square meter, per cubic meter. Let's say you have a permeability, you have a cubic meter of gravel, and you have a permeability of 30%, 40%. Then you know, 400 kilograms of resin will fit to close all that permeability in that cubic meter. This gives you a rough indication. Then you have flowing measurements that you should use, which gives you an indication how many material I injected into the soil in that lens, a flow measurement. And last but not least, the pressure increasing, which you can measure on the flow measurement or on the pump. And I always recommend soil improvement under foundations, slab lifting. We did some projects. Always place a laser measurement on top of it. To your last question, what can be the worst case scenario? An unwanted lifting. This is the worst case scenario. But you remember the toolbox adjustability of the material gives you more safety. That means if you accelerate it faster, then the chance that you have a lifting is less compared to a high foaming volume. This is what, it's not easy. It's not an easy job, but it can be done properly by taking care of some parts we talked about now. You're welcome.
Excuse me. Thank you, Stephen, for this wonderful session, technical session. My question is, you have shown the case studies of tunnels. Do you have any case study of mega structures in thermal power plant like chimneys or cooling tower, especially cooling tower?
Cooling tower means crack injection in...
Yeah, any product of Webac which can be used in mega structures like cooling tower and chimney, basically.
There are some special, or let's say some polyurethane modifications we have, which means where we have a higher chemical resistance against some substrates. Maybe they are there, or if we speak about higher load that we have to, or strength which we have to give to these kinds of structural, and there are some products available. These really has to be decided with the designer himself. What he wants, we can achieve.
No, but cracks are already there, always there in cooling tower, which is a water structure. So to repair that cracks, only particular products can be used by the applicator. So can we use any special product as a Webac product?
If I know what water, let's say if the water is contaminated or something like that, is it contaminated, or do we speak about...
the pH value is higher there.
Then we can speak with our research and development. You remember, maybe we can create a formulation which fits to that case.
Right.
Sorry that I have no other answer for that. But it's possible, it's possible. Okay, any further questions so far? I'm not sure, Yogesh, are we in good shape or?
So, one more question, please. See, if there is a leakage, then after successful application of any engineering product, if the water stops, then we assume that the treatment given was right. But what if there is no leakage and there is the issue of soil stabilization or ground deployment technique? So how to decide that the job done perfectly? How to proof check it?
Yeah, good question. It's difficult to answer.
The client will ask what you have done. Show me that you have done correctly.
Yeah.
We won't release the payment.
I recommend. A good point. In this case, I can answer: take a core. Take a core out of the structure and see the result. Do a core drilling. Doesn't need that dimension. And see the result. Did you achieve it? Did you fill the crack properly? This is the only, from my opinion, the only thing you can get an overview, an inside view about your application. Because how can you see it? You can't see it.
That's right.
And if the waterproofing is, let's say, if it's easy, if the water is coming out of the crack, that is easy. Then you see it. Then you see it.
Yes.
But if there's no water leakage, it's the only thing I recommend is core drilling to get an overview about what is inside the structure.
Struggling with the same projects in Mumbai itself.
Yeah, and I know it's not only in Mumbai, it's also in Germany. Or to convince a client to do a core drilling is difficult because the damage is building. Yeah, blah blah blah. But this can be repaired with a lot of sufficient product. But this is the only thing you can. Or let's say. Okay, there's another thing you can convince him. Let's say we have a crack of 1 meter length, and we have, let's say, just a rough 30 or 40 centimeter thickness of the structure, and it's dry. And you want to get knowledge: is it sealed or not? The thing that is common, or I use sometimes, let's say, I know for a crack repair in dry conditions, by using an epoxy, for example, I know I need more or less maximum 1 kilogram. And if you remember, if you install the packer properly, that means not the packer here and at the end of the crack, but in between, in a certain distance, half of the thickness of the structure, that's what the norm says, then you get also a calculation, or then you get a visible observation of your proper filling. You inject there, material comes out there at the end. Remember, during the pot life, go back and refill it again. Then you can say it is, I would say, nearly 90% filled. This is the only thing where you can also get an overview. I know it's difficult, but this I use, all my colleagues, we are using for such cases. If you're not allowed, you have to control what you do. And if you calculate it, it's a rough thumb rule, but it will work.
Actually, the problem is, the real struggle is to make the client understand the problem is not on the superstructure, but the substructure.
Yeah.
The first challenge is this.
Yeah.
Second is application, and again the third is whatever done well, that is right or wrong.
It's not here, it's not only here, it's also around each job site. To convince the client and to say, look, yeah, how can I convince you? We have the calculation, we have the design, we can carry out a test injection if you want to pay it. These are the options that you have. Sorry that I have no other answer. So, any other questions so far? Oh, sorry.
Adding more accelerator, is it affect view life?
The what life?
Adding more hardener accelerator, is it affect view life?
No. The only effect you achieve is a faster reaction. A faster reaction of the materials. It has no influence of the, let's say, of the durability of the material.
So we can add any amount of accelerator, it will not affect view life.
Not our resin, but I wouldn't recommend it. Depending on the case, sorry. The target is, let's say, if you inject the polyurethane resin and you have a thick structure and you have, let's say, water pushing out, the achievement here is to inject in the depth of the structure as good as possible. And if you think, oh, it will get washed out, yes, by adding more accelerator that creates a faster reacting, that creates only a sealing in the thickness of this, but you need a sealing of that. So this is difficult decision, but come back to your question, it will not have any impact of the shelf life or of the long life, less time of the material. Sorry.
Yeah, Stephen, have you tested your these products for longevity of this life?
This is a good question. Our products are, let's say, we have some reports, we have some sites where we applied our material 30, 40 years. We have some reports which shows it is cured also after that long time of period. And this is a good question because we will get asked this question for bigger projects, tunnels or underground, because you have to give the guarantee that it takes 100 years of lifetime.
Because all the tunnels and all the infrastructure is designed for 100 years.
Yeah, I can sign that. I'm 58 now. I will never see the result after that. But I understand that point. But what we can say, if the products will apply in a good way, mixture, application himself, the usage of the tunnel or of the building will be not change in a certain amount, more load on top or more movements. Then we can guarantee, and that's what we do for projects, we guarantee a shelf life, let's say, of 100 years, 150 years.
Do you give in that for that product?
We do it with a with a Webac certificate, that we say, okay, under that circumstances, under that we guarantee a life of 100 years, for example. But like I said, usage can change, tunnel can change, everything has to be in a proper way. And as far as I know, correct me or I'm wrong, but there are other suppliers do the same. Oh,
Would you please explain more about your B-Seal product?
okay. B-Seal product is our polymeric reinforced acrylic gel. So you remember, Webac 240 is the, let's say, the mother product, where we have a good adhesion, and the application for that product is curtain injection. Curtain injection behind structures to give a waterproofing, chemical waterproofing membrane. The B-Seal, because of the reinforcement component, develops a higher strength development, which is much more higher compared to the standard gel. And there we have a high adhesion. We have a higher chemical resistance, we have less shrinkage, and we have, I explained it, we have a version, or by adding less amount of salt, which is the reaction starter. I hope that everyone knows that acrylic gel needs a reaction starter, which is a salt-based starter. By minimizing this, and in combination with the polymeric reinforcement, it can be used for crack repair in concrete structure. We have a test certificate. Maybe you think, reinforcement, corrosion. No, we have test certificate that we are that we can inject it, and we not create any corrosion to the reinforcement inside.
The video you were showing that panels were moving.
Yeah.
And my question here is, does that require some surface preparation?
No. Okay. Surface preparation or joint preparation like this. Sometimes you have, let's say, insulation. You have concrete slab. Inside the joint you have insulation or styropor, for example. This has to be removed if you can do it, and you have to clean it. And if it's wet or dry, or water saturated, remember that a joint project doesn't matter. It develops a joint adhesion, and this is also because of that slightly swelling effect of an acrylic gel. You push the gel to your joint edges or back edges, and it creates, because of that polymeric milk, creates a higher adhesion to the substrate.
So you are saying that we do not need to grind the surface for the edge preparation, just like we do for some kind of an expansion joint or so?
Here we speak about movement joints.
Yeah.
These are usually 2 centimeters, or I guess it's open. So you have to remove, let's say, the The parts which is inside the crack, which is inside the joint, that's flush it with water, for example, make it clean. That's enough. That's enough to.
Do we have any data on the bond strength?
Bonding strength.
Yeah.
We have it in the technical data sheet. We can prevent it later on.
And what will be the joint size it will be able to accommodate?
The maximum.
Yeah.
The widest, I guess, was 8 centimeters, roughly like that. Okay, sometimes you come to a certain point where it's too wide, but from my experience, most of the movement joints are between 1 centimeter, 3 centimeters, sometimes 5, but this is the range that you can apply. But like I said, it should be clear that no dirt or something is inside, and as wider the joint is, the better preparation, like the cleaning of the joint should be done. Because then you create a good adhesion to the mineral substrate.
I had seen that tie rod hold good actually. So what is the life of that once it is sealed, that tie rod holds?
You mean that
Yes, exactly.
that maybe can Yogesh explain a little bit deeper because it's more his business.
The epidemium, the life of epidemium is about 50 years.
So it's not our.
Because major that basements tie rod holes will be sealed with that kind of material only.
Yeah, we use, for example, we use other sealing. We use swellable products. So hammer-in plop you put in with a swellable rubber inside that swells up and seals it. Or I did a lot of injection with polyurethane resin through that tie rod sealings by using Webac 1403.
Can you tell me more about that tube which you had shown, that tube to put in that joints or seal the construction joint? Yes.
Are the packers?
Not tube.
The
Injectable hoses.
Yeah.
The injection tubes. The injection hose. Okay, this is a thing. You let's say standard, or if you have a concrete slab and you build up your wall, you use swellable products, swellable tape in the middle of the concrete, 2 rows depending on the thickness, and then they swell up and they will do the waterproofing, polymeric or bituminous, whatever material. The advantage with it will work, okay, but there's maybe some failures. Reinforcement drops down on it, damage, or the overlapping isn't in a good shape. An alternative product is an injection hose, a simple hose with some openings, which you apply in the middle of your concrete structure, similar to the swelling products. You have an outcome, you have an opening on each side, which comes out, which will be placed in front of after your wall is poured, and you can inject it after 28 days, for example, or after 1 year, after 5 years, after leakage is coming. This is the advantage that you have. That means you don't have to drill if a leakage is coming in the future, and which is a good alternative and a cheap alternative for new buildings. And they will be used on a lot of job sites. A cheap solution, alternative, or a combination between swellable and injection tube. And they can be injected with polyurethane resin, epoxy resin, or acrylic gel, doesn't matter, or cementitious grouting also. Yep.
Now, before I conclude, I request, we also have a national team member of Waterproofing Association of India. So I request Madhu sir to felicitate Mr. Kunjan. A round of applause, please. Thank you so much. I would thank Stephen for so much beautiful presentation, and it was really knowledge driven, technology driven, everything in it. Lastly, I would like to conclude by saying your presence here adds immense value to this knowledge exchange. Together, we look forward to creating strong bridges with German engineering excellence and Indian waterproofing community. Bridging nations is not about borders, but about ideas and excellence. And now, our next meeting will be in World of Concrete, 8 to 10 October. I will see you all over there. Thank you. We have an exhibition over here. You can see the products, kits, and buffet is open with drinks. And I think you should all enjoy it now and have an interactive session. Thank you so much.
जैसा वो सेशन चालू वो लगा दिया मेरे को वगैरह का इनको मैं हाथ में लेके आ गया तो मैंने नहीं बोला ना यहाँ से इसलिए मुझे से वो भी एकदम सेंटर एंगल थोड़ा सा एंगल
इसको तो कल ही नहीं
तुमने भी अभी तुम मारे थे फोटो एकदम सेंटर पकड़ लिया थोड़ा सा मेरे को एंगल लेकर लेके दोनों का सेल्फी देखते जो मेरे गलती अभी कैसे और वो उसमें क्या करें